All right, welcome to 9.3 day 2. So last week, if you remember, the first day of 9.3, we looked at half angle and double angle identities and how we apply those. Now today we're just going to look at how we can kind of go the opposite direction. If we're given like a general form, how do we evaluate that, simplify that down to be a single trigonometric expression? So here are our first two examples. You're going to want to have your formula sheet readily available. So if you look here, this first example takes on the form let's redo that here, make that a little smaller. Bear with me here for a minute. There we go, let's try again. 2 tan theta, we'll say 1 minus tan squared theta, where theta equals 33 degrees in this example. Okay, so if you look, that general form, if you look in your double angle identities, is the double angle for tangent. So tangent of 2 theta is what this will be equal to. Now, since our angle is 33 degrees, this is just going to be tangent of 2 times 66, getting ahead of myself, 2 times 33 degrees, which is tangent of 66 degrees. So it's kind of the idea of what we're getting at with these problems today. If we look at the next example, this is in the form 2 sine theta cosine theta, which if you look at your double angle identities is the double angle for sine. So that's equal to 2 sine 2 theta, In this case, theta is equal to 45 degrees. So if we plug that in, we would get sine of 2 times 45 degrees, which is just sine of 90 degrees. Now, this example, 90 degrees is on our unit circle. Sine of 90 degrees is equal to 1. So we would want to simplify that all the way down if we could. In the previous example for tangent, however, tangent of 66 degrees, that's not a nice degree measure. We don't have nice coordinates for that. So we'll just leave that as tangent of 66 degrees. So simplify when you can. If you can't, you don't have to. All right, next we're going to look at these two. So this next example takes on the form 2 cosine squared theta minus 1. So in this case, theta equals 30 degrees. And if you look at your formula sheet, 2 cosine squared theta minus 1, that takes on the form of cosine of 2 theta. So since theta is 30 degrees, cosine of 2 times 30 degrees. So this is cosine of 60 degrees. And if you look at your unit circle, 60 degrees, cosine there is 1/2. So simplify this down if you can. So that would be equal to 1/2. All right, 1 minus 2 sine squared theta, where in this case theta equals 25 degrees. If I refer to my formula sheet, that's another cosine double angle identity. So this is equal to cosine of 2 theta. So cosine of 2 times 25, which is cosine of 50 degrees. And 50 degrees, we can't simplify cosine of 50 degrees anymore, at least using our unit circle. All right, so then this one, cosine squared theta minus 9 sine squared theta. If you look at your formula sheet, you don't see anything that has 9 times in front of it, right? 9 times cosine minus 9 sine squared. So what we're going to do is I'm going to factor out that 9. So 9 times cosine squared theta times sine squared theta. Now, this cosine squared theta minus sine squared theta, that, if you refer to your formula sheet, is another double angle for cosine. So this would just simplify to 9 times cosine of 2 theta. Theta is equal to pi over 3. So 9 times cosine of 2 times pi over 3. So 9 times cosine of 2 pi over 3. Cosine of 2 pi over 3 is, if we look at our unit circle, negative 1/2. So this is going to be the same as 9 times negative 1/2. So negative 9/2, if you simplify that all the way down. So sometimes you may have to factor something out of there in order to continue simplifying. So if you don't see the identity right away, try and see if you can factor something out. All right, so with this particular double angle for cosine, the cosine squared minus sine squared identity, a lot of times people will get that confused with the Pythagorean identity. So the Pythagorean identity, remember, is sine squared plus cosine squared equals 1, and that's on your formula sheet. So we can also, since addition is commutative, say cosine squared plus sine squared equals 1. So in this first example here, cosine squared of theta plus sine squared of theta, well, we just said if it's cosine squared plus sine squared or vice versa, no matter what, that's going to equal 1. So if it's just a simple addition of cosine squared and sine squared, no matter what this angle is inside, it will equal 1. All right, now we have a different case here. We have sine squared of 25 minus cosine squared of 25. That is not your Pythagorean identity, and that's not your double angle identity for cosine. Because remember, cosine of 2 theta is equal to cosine squared minus sine squared theta. Okay. So what you're going to want to do then, if it doesn't look like either version, see if you can factor out a negative. So in this case, we're going to factor out a negative 1. So that would mean we'd have to multiply by negative sine squared plus cosine squared. So now if we rearrange, we have negative cosine squared theta minus sine squared theta. And if you look, that cosine squared theta minus sine squared theta is your double angle identity for cosine. And in this case, theta is 25. So this is equal to negative cosine of 50 degrees. Okay. All right, and then something similar in this last example, negative cosine squared minus sine squared. So they both have a negative in front, and neither looks like the Pythagorean or the cosine double angle. So let's take a look and just try and factor out that negative. So you get negative times cosine squared plus sine squared. So we get a negative, and then this is your Pythagorean identity, cosine squared plus sine squared. So this will just equal negative 1. So always keep in mind that difference between what your Pythagorean identity is and then what your double angle identity is for cosine, and try and distinguish between those two. And then lastly, we're going to move on to some half angles. So if you look at your half angle formula box on your formula sheet, what we see here is the positive square root of 1 minus cosine of 90 over 2. So square root of 1 minus cosine theta over 2, that looks like it is the half angle for sine. So this is equal to sine of theta over 2. And our theta value is 90 degrees. So this is sine of 90 degrees over 2. So sine of 45 degrees. And using our unit circle, we should get sine of 45 degrees is root 2 over 2. Next example, square root of 1 plus cosine theta over 2. In this case, theta equals 90 degrees. And that looks like the half angle for cosine. So this is equal to cosine of theta over 2. So cosine of 90 degrees over 2. So cosine of 45 degrees Cosine of 45 degrees is square root of 2 over 2. So I hope that helped you see how we can work backwards. You can finish up the 9.3 worksheet if you haven't already. And then your daily task today will be another 9.3 LT check labeled with the date on it. Thanks and have a good day. See you tomorrow.